Hey guys, welcome back to Ox Tools. I'm Tom. So today we have a little project that I think you guys will get a kick out of. We're going to make a special indicator holder that fits an R8 taper. So a lot of guys out there have R8 tapers, so this should be of interest to them. We're going to get to use our cool little angle blocks, our angle gauge blocks that we just got to set the precision compound angle, so that'll be kind of neat to try those out. So let's take a look at my little chicken sketch, and you can kind of see where I'm headed with this thing, and let's get started on it. Okay, so here's what we're doing. So I did a kind of a preliminary notebook sketch, and then I cleaned it up a bit, and yeah, you guys can see that okay. So here's what we're doing. I've got some of these real powerful neodymium magnets here, and these are these nickel-plated ones that you see all over the place these days, and they're really powerful, and you can use them for all kinds of neat stuff. So here's the general idea of this device. This is going to fit in the R8 spindle. So this particular included angle matches the R8, and then we're going to create a little pocket for one of these magnets. Here, there it is. One of these magnets, and then we're going to epoxy that magnet in there. Now, there'll be a through hole here, and then this gets tapped at this end here. Now this is a cross section, guys, just so you know. We're going to attach one of these cool Nogaflex holders here, one of these arms. I've got two of them here, and there's the model numbers there. Let's see, make sure you guys can see that. Hopefully it's not reflecting too much. So we got an LC 6100, and we've got an NF 6003, okay? And I'll show you those in just a sec. So those are going to attach to this lower end and mount an indicator, okay? So the interesting parts of this project are, once again, we're going to be setting a short taper precision angle here, and in this case, the Bridgeport R8 is 16 degrees, 51 minute included angle, and that means both sides of the angle there. And so we're going to be setting the half angle, so decimal degrees, that's 8.425 degrees, or degrees, minutes, and seconds, it's 8 degrees, 25 minutes, and 30 seconds. So a lot of guys were wondering, hey, when the heck are you ever going to use those seconds blocks in that angle gauge block set? Well, there you go. We're going to use some of those seconds blocks right away, okay? So we get to play with those. That's cool. And so Noga sent me some tools for testing, okay? I asked for some, and they obliged, which is really cool. And they sent me a little box of stuff, and one of the things is for this project. So we're going to look at some of the other stuff later on. So these are two of their small articulating arms here. And this is the very smallest one here, and isn't that cool? Look at that. So this is their normal, cool, excellent quality here, and yes, I like Noga, so just get over it, okay? And so this is the itty bitty one here, and then this one, I wasn't sure what size was going to work out the best, so I went ahead and got two of them, and you can see the, let's see, I want to orient these the same. Oh, I guess that one's kind of the same on both sides. So this one's got a taper to it. It starts out big here and then tapers down, and this one looks like it's kind of the same size through. So there's the relative size difference. They're not much different in length, but they both have an M6 in them, which will go into our little adapter here. So let's go play with some gauge blocks. Let's go over to the lathe. We'll spin a little part out. We're going to make this out of aluminum. And the general idea is that this magnet will be in here, and I'm hoping the aluminum doesn't interfere with these flux lines too much, and that we still get enough attraction through to lock that thing in the spindle. So let's go, let's get cracking. All right, so we got a piece of material here for our R8 adapter. What is this? 2 1/4. So let's get her centered up here in our 4-jaw chuck, a la A-bomb. And I use this, you know, when I'm just kind of roughing in here, I use this the small handle, and then I'll switch over to the big handle in a sec. Let's see, make sure I got enough sticking out. We need 1 3/8 plus a part. That should be plenty. It's nice and stiff. Don't have to worry about it. Okay. All right, it's not too far off. There's a spindicator here. Okay, let's see here. So that's the low. That's the low. Kind of close. Start cranking it down. Let me go around and make sure these are kind of getting equal. And we can do the fine adjust from there. All right, what do we got? Oop, I'm reading it wrong. That's the high. That's kind of a bumpy piece there, so I'm not going to sweat it too much. We're turning the whole thing, so make sure we're all tight all the way around. Yes. Yes. All right. All right, so we're going to use a turning tool here, and this is one of my favorites for soft materials. This is a CCGT. It's a polished insert, very high positive. This you could shave with this thing, okay? This one happens to be a Vardex, although a lot of people make an equivalent of that, but it works really good on aluminum. So, and soft materials like copper and bronze, and generally kind of softer materials. All right, let's see what we got here. Sure, why not? You see how bright the chips are coming off of that? That's that polished insert. I'm just getting an end kind of flattened off here. And then actually, you know what? I want some more spindle speed here. Let's see. Yeah, that's better. All right, I'm at 0 here. 0 the DRO. And then I'm going to calibrate the diameter here in just a sec. I think I'll change the camera angle for that. So, all right, we're going to calibrate the tool diameter, or the x-axis here. I'm just going to get a actually. So I had a little built-up edge on there that I was knocking off. I don't want to get a false reading there. So it doesn't really matter. I just want to take a light cut that cleans it up. Like that, and enough to get the micrometer on, like about that much. Alright, and then we'll take a micrometer and we'll get a so I look for the nice slip like that, you know, when you're on the diameter, you can feel it. It feels like it's greased. Alright, so that's 225, 43. And then we're going to calibrate. 2.2, oops. Yeah, 2 point. Alright, you little piece of junk. 2.242. Enter. Huh. I hit the 0 button or something a couple of times in a row there. All right. So now we got a calibrated tool. We're 0 on the Z and we're 0 on the X, so we can get our little chicken sketch going here and do all the rough turning and drilling, and then we'll cut our included angle for the R8 taper, which will be kind of fun. So. Alright, so first step here, we're going to turn it back to 2-inch diameter back. The length of our part plus a parting blade width plus a little bit. So you know, that's about 1.5 inches in this case here. And then I'm just going to give it a little spritz of WD as a cutting. Yeah, I'll probably do this in 2 whacks here. Sure, why not? I'll slow the feed rate down for a fine finish. Alright, that's plenty. And then slow the feed rate down. We'll go right to our diameter, which is 2 inch. You know what? I gotta open the window here. These chips out of the way here. Long stringy buggers. Alright. Okay, so that feels nice. Alright, so let's we're gonna do our secondary diameter, which is 1.25. And that goes back, what, 1 inch, all right? We're going to take a big cut here, a pretty big one. $8.95 to start with. And then, bits. So I'm establishing the shoulder. All right. And we'll leave a little bit for a finish cut. One more pass after this. What I want to do is take some off of that shoulder first before I do the finish pass, and I can do a continuous cut. Come back, slow the feed rate down, and then we go right to my 1.25 now, and then I'm going to come up to my excuse me, I got a burr in my saddle. I'll come up right to that shoulder, then I'll feed out. And I'm going to come out. Like so. Alright, looks pretty good. Alright. Alright, that's pretty tasty. Let's see. See how this is here. See if this isn't really an important diameter here. It's just I want to see how well the DRO is tracking. Okay, it's 1 thou under, which is fine for this deal here. That's nothing goes on that diameter. So let me break a couple of edges, and then we're going to set up our precision internal spindle angle. That, what is it, 16.5 degrees or whatever it is, and then we'll put that angle on there. All right, so remember I said we're gonna get to use our cool new angle gauge blocks. So let's make up a stack of our blocks that equals the half angle of the R8. Actually, you know what? I'm gonna take that out of the way. See, these are the Starrett-Weber angle gauge blocks here. So our angle is, oops, where's my paper? Gosh darn it, let me get the paper. Okay, so we're going for 8 degrees, 25 minutes, and 30 seconds. So what we're going to do is we're going to make up a stack. So there's a 5 degree, and there's a 3 degree, okay. And then we need a 20 minute. Okay, and these are marked what end is what. So it says plus and minus, so we know which is the big end and the small end. Okay, that's 20 minutes. Then we need a 5 minute. That's a 5 minute. Okay, and then a 30 second. Okay, 30 second. There's a 30 second, and that's the plus end. Okay, so there's our half angle stack there. Now, you know, when these blocks are new, they're really nice and they ring together really well. This particular set has been used a fair amount, so they don't all ring together real nice. You know, the angles are still pretty good, but they probably need a calibration certainly to see where they are. And Starrett will recondition these too, but I don't know if I could afford that. So okay. So there's our cool little stack, and that represents that half angle of the R8 taper. And hopefully this will blow out the camera exposure. It kind of does. That's our little chicken sketch there. All right, so let's cruise over to the lathe and see if we can set that compound rest at this angle real nicely. Okay, so let's set our angle now. And so we're gonna slacken the compound here. And we're going to be going past parallel. We're going to be going this, our 8.5 or 8.4 degrees past, so we'll cut that angle that way, beyond center. So let's loosen this up, and what we'll do now is we'll get a just a kind of an eyeball setting here. There's 8. I'm just going to kind of eyeball about 8.5 degrees. That's about as close as I can see without my big magnifiers on there. And then I'm just going to put a whisper of tension on these. Actually, you know what? I probably should have taken the compound, or excuse me, loosen the quick change tool post here a little bit, but too late now. Well, it's not too late. You know what? Let's do that. Let's just do it before we get all fussed out here. I think I'm just going to pop that little monkey off. Set that aside for a minute, just so you guys can see what's going on here. All right, so oops. All right, loosen that up again. I tightened it up so I could crack that bolt. Okay, so now we're loose, and now we're going to put our cool little stack of angle gauge blocks that we made up over there. So there's our 5, 8 degrees, 20 minute or 25 minutes and 30 seconds. Pretty cool, huh? And so we're just going to align that with this edge here. Just eyeball. No, just kidding. We'll stack those up. And then, so you can see probably on the video that this is, you know, basically parallel with the ways, and that's what we're going to be checking for in this case here. So now what we need to do is indicate along that and make sure that it is indeed parallel. So we're going to make this a Nogalicious day here. We're going to use all our Noga stuff. So what I want is a little fence on this here. So I'm going to pop this magnet on here like so. Something like that. And this is just going to create an edge here, and I'll bring this up to it. And it'll probably snap up to it very nicely. Okay, so now we got a good registration with that edge using our Noga magnet. And now we need an indicator. So we're going to indicate along this. So we need a fixed point, and then we're going to traverse this axis here, okay, to determine that when that's straight with the world. And I'm just going to snap this little guy on here. Let's see, yeah, that looks okay. And bring it over, something like that. And I'm going to move the camera so you guys can see all this in living color here. But this is the general idea here. We'll bring that up like so. And then we're just going to go. It probably won't make that noise, but that's what we're going to do. So let me just rotate that down. That looks pretty good. All right, so let me reset the camera so you guys can see this properly from probably over this way somewhere. And we'll indicate that, and we'll bop it around, and then we'll lock this down and get our compound set at our 8 degrees, 25 minutes and 30 seconds. Alrighty, so let's get zeroed up on this. So we're up against that, and let's just take an initial sweep here and see what we got. Okay, so it's getting bigger this way, so we're too far that way. So I'm just going to kind of bop this back. Oop, that's not bad. Let's get another pick on that. All right, well, okay. So sometimes you get, that wasn't very exciting for you guys, but it was pretty exciting for me. I got it in one bop, and that wasn't planned, no matter what you might think. So let's see if we can hang on to that setting there. Kind of hand tighten those. pretty damn tasty to me for what we're doing here. Alright, I see the indicator moving a little bit, but it may just be settling in general and not turning necessarily, so we're gonna go ahead and put a little tension on all of them. Okay, and then give it another whack. Okay, that's pretty damn good. So, okay, so now we got our half angle set. Okay, our 8.425 degrees or 8 degrees, 25 minutes, 30 seconds. So let's clear this off. We'll put the tool post back on, and then we'll machine an R8 taper on the end of that. Okay, so get the tool post back on. What we're going to do is come up and calibrate the tool on the diameter. I've got the compound zeroed. You don't really need to see that because I want to be able to go back to a starting place. Whenever you're doing an angle like this, it's sometimes very useful to be able to go back to where you kind of started the whole thing, so you can kind of work out where you were. So let's get a little touch off on this. Okay, and that's fine for what we're doing. Oops, it's the X, and then I'm going to get a little touch off on the Z here. Okay, good enough. All right. So now I can advance the compound rest at our angle, and what we're doing is we're cutting an angle, but the angle's going to exit the diameter in this region here. Actually, we're looking for about 1/8 between this surface here and the line that it creates when that angle comes off of the surface. And you know, since it's a taper, it's always going to go together, right? And so we'll be scaling that 1/8. I think in this case, it's all that matters. So I don't know what else. What else can I say about that? Not much. So anyway, so that's where that angle is going to come out, and I think we're kind of ready to go. Let's see. I got the hole to put in there too. Should I do that first? You know, I don't think it's going to matter in this case because there's still going to be plenty of meat around that. So here's what I'm considering, just so you guys understand what I'm thinking about. There's a 1/2 inch hole, or a little over a 1/2 inch hole that goes through here like this that holds the magnet. If this wall thickness here across here was getting real thin, I would probably want to put that hole in first, or at least rough it, and then cut this angle away, and then finish the bore, and then finish the angle. You know, you kind of bring these features in together to hold accuracy, but this thing's pretty stubby and stout and thick walled, so I'm not gonna sweat it too much. In kind of the end uses, doesn't really matter for us. You know, it's basically just got to go in the spindle and stay in there. Okay, so let's go ahead and we'll put that angle on there, and then we'll drill a hole through for the tap, this M6, and then we'll make a counter bore for the magnet, and then go from there. All right, you boys ready? All right, I am. I'm gonna go to off of 0 a little bit. Come up, and we're gonna take an initial cut to see where it comes out. We want to undershoot in this case here. So you see what I mean? You want to undershoot, and it's really easy to overshoot when you're dealing with angles. So we're going to creep in a little bit. You see how much it advanced along the length of it? So we got to start getting real careful here. I'm taking lighter cuts now. And I can cut on the backstroke too if I want. And sometimes that's useful because you can see the touch off. I'll do that in this case. I'm just going to advance in until I see a witness mark. Okay, I just touched off there. You can see the line. Now I'm going to back up on it. And sometimes you get a really good finish going backwards too. In this case, actually I'm getting really close here, so better pay attention to what I'm doing here. Let's use this scale here. Okay, so I'm about 150 right now. So I gotta start paying attention. Let's give it a little spritz of liquid love there. Now I want to try to feed real smooth. Carried away here. Alright, we still got a little bit. I'm just going to advance a couple thousandths and then I'm going to come back. I still got more to go, so I'll just go quick here. Okay, and come in a little bit. Pretty good there. Got a nice finish. I'm right at an eighth of an inch. I'm calling it good. All right. Yeah, it looks nice. So I'll break this edge. Probably do a little polish on that just so it's super smooth. Let's work that hole, and then we'll get this thing lopped off and tap the other side. Alright, so I think we're ready to poke some holes. So now what I'm going to do here, actually let me turn this off for a sec. What I'm going to, maybe I'll turn this drill so you guys can see that a little bit better, okay? So just to get a rough depth on this hole, what I'm going to do is I'm going to drill in until this corner meets that surface. And then I have a readout on the, or not a digital readout, but a scale that a rotary scale on the tailstock, so I can tell how far I'm advancing in. So I'll advance in, and then we'll try one of the magnets in there. Actually, yes, we'll try. Yeah, we'll go ahead and try one of the magnets in there, and you know, look at the depth and make sure we're happy with it, and we'll go from there. So, all right, let's do that. Chattering nicely, of course. It's because I'm feeding lightly is part of the problem. But this corner is touching now, so I can zero my my scale here, and we're going in about 230, or excuse me, 260. 260. I better look at the drawing. Yeah, that's why you make a drawing. It's 280. 275. Okay, that's close enough. Because I'm going to finish the rest of it. I'm going to finish the rest of it with the boring bar. Now that nasty chatter was related to the center drilling. Okay, so and you notice the chatter went away. This is a nice sharp drill. The chatter went away once I got into solid materials. So now we're going to bore that to open that hole up to make room for epoxy. Let's just see if it came out a little bit oversized, which usually, yeah, of course, 501. I don't know if that thing's going to go in there. We'll see. Let me grab a magnet and we'll check it out. All right, so there's one of the magnets. Let's see what we got here. Oh yeah, I don't want to. Oh no, it's okay. That's pretty good. So this gives us and I'm going to bore just a little bit deeper. A little room to backfill the top with epoxy so we don't have metal or the metal of the magnet exposed. So we're going to sink it in just a little more than that, but that's the problem with magnets. They stick to everything. And these are strong little bugs here. So anyway, maybe I want a little bit of room for epoxy around the magnet. So and then I want it subsurface. So I'm going to drill the 5mm through, bore that just a whisker to clean that, and then I think we're done with this side. Alright, there's 280. Alright, so let's clean that up. Let's do our little depth check here and see what we got. Yeah, okay, I think that's pretty good. That lets us have a little film of epoxy over that surface there. So I think I'm just going to break that edge just a teeny bit and then call that bore good. All right, so let's give this thing a little bit of a. What do we want? I want to shine it a little bit. Do we have some gray here? Oh, yeah, there's a little piece. I'm just going to give it a. While it's still on the. Mount it to the spud here. Give it a little shine up here. Not much. This rag's dirty. Alright, so now we're going to lop this off. There. I've reset the compound back off camera and stuff. It's not important for this discussion. All right. Oh, I'm going to zero that actually because I'm going to start the groove. And when I get in a little ways here, I'm going to come out of there. And I'm going to put my chamfer tool in, come back and kiss that edge before I knock it off, and then make it harder to get at. We'll see what that face looks like. It's possible we'll come back and face that to make it look real spiffy, but we'll see what we get. I try to go for the rock star thing, but doesn't always work out. All right, let's continue on. We got a pretty deep part. We got to go down to that 5mm hole. And that's, we call that a record player there. See, it's coming out like a little record player. Okay, we're getting down there. Okay. Alright, that's not bad. I think that's workable. Okay. Let's see what we got. Oh yeah, that'll be okay. So, take that little chingus off of there. And then we'll tap that. And then we're going to give this thing a little try. Okay, so I'm going to tap that, and then we'll glue this up and play with it tomorrow. Okay, so I think we're kind of ready here. I got the magnet in a piece of tape because it had some dust on it that I want to get out. So I want to plug that little hole because I don't want the epoxy to drool down that little hole. So I was looking for a piece of rubber and I didn't have any, so I found a little hunk of leather here. And my plan, this is the master plan here, is that I'm going to just cut a little slug out of that. Go through yet? No. Okay, I think I went through that time, yeah, okay. And then I'm going to pop that little bead. God dang it. Rats. Oh, is that it? No. Not it, damn it. Alright, well. Hey, fortunately I have more leather. Oh well, it's lost to the nether regions there. Alright, so let's be a little more careful here. Okay. So, that looks too small. Yeah, it's too small. Okay. This is a set for cutting corks. You know, for laboratory stuff where you have to put a you know, a glass tube or a pipette or something through a stopper. Now, this one's probably too big because these are standard labs deals. So don't do this on top of your finger. I'll give you. Oh. Alright. And then it's got a little extractor deal. Okay, yeah, that one looks pretty good. So the idea is that goes in there. This is the theory anyway. Okay, now it's going to work. Okay, and then this keeps epoxy from running down that hole and getting away from me there. So let's put this away here. Alright, okay. Alright, so I think we're ready to mix some epoxy here. And this is this real fast setting stuff here. So it's got a kind of a, I would call it a limited pot life. Let's do it like this. We don't need very much. Get it out of our way. So whenever you're doing two-part epoxies is you really want to mix them really good. Get all the juju together. And you see this is relatively runny, but now I don't have a lot of time here, so I can't sit there and fart around too much. Oops. So I get it. Yeah, I'm pretty sure I got way too much in there. Actually, I should probably dig a little out of there. So that's the other thing is volumetrically you got to be kind of. All right, you know what? It's probably better if it overflows a little bit than if you underfill it. So if you ever get crud on a magnet, you can wipe it off sometimes with sticky tape to get the little particulates and crud out of there. All right, and you got to get rid of that. All right. Okay, come on, Mr. Wizard. Oh yeah, damn hydraulic fit. I just have a feeling I'm going to stuff my hand in that. I'm trying to force some of the air out of there. All right. Well, it looks like I might have probably gone a little deeper on that. Okay, note to self, make that pocket a little deeper. And basically, I'm just, like I said before, I'm just trying to cover up the metal here. All right. So I decree that is time to get off the horse. I don't think I'm going to improve it any. Of course, my brain is going, go ahead, try, Mr. Dumbbell. Just go for it. Poked on that a little bit more. You can do it. Come on, just go for it. All right, if you insist. All right, I can feel it. It's starting to kick there. Okay. All right, so I'm going to let that cure, and then we'll put the stud on the other side. Then we can give this thing a go. Okay, so moment of truth here. That feels, I don't know, it feels pretty good. Let's give this a little poke and see here. Oh yeah, that's nice and hard. Okay, well here's the general idea is that this will stay in here. Oops. Well, it wants to grab the surface pretty good. I don't know. It's not very strong. It's okay there. So the flux lines are going like this, right? So this may be returning the flux lines a little differently here. On the end, it's still close to the surface, so it grabs pretty good. But I was hoping that we have a little bit more than that. I don't think that's enough to hang an indicator on. Okay, well, I gotta go back and do some magnetic calculations there and see what I need. Well, all right, well, it looks like I got to do a little thinking there. I think I'm going to look at putting one in normal to this angled surface here. That way it'll attract directly against the spindle. But there's this fine line between too much and not enough, right? And well, we're at the not enough side right now. So it looks like there's going to be a part 2 to this, guys. Let me go back and take a look at that. Thanks for watching.